Hello everyone, welcome to Reactify Labs. Today we will do another Leetcode problem which is called trapping rainwater. It is problem number 42 on Leetcode and it is also tagged as a hard problem. And it is a hard problem but not too hard. Okay, it's a manageable hard problem. That's why these kinds of questions are asked a lot in the interviews. So the interviews, if it's a company which is having sane people and the interviewer is also a sane person, then he or she knows that you should ask that kind of question in the interview which actually a candidate can think and solve. Okay, or if it is either a very famous problem. Okay, because in interview you hardly get, I think, 30 minutes 30 minutes to think and solve the question, because initial 10 minutes are usually in the introduction, last 5 minutes is for your questions, 10 to 15 minutes is for your behavioral questions. If the round demands so, then you are left with again 30 to 35 minutes, and out of which again 5 minutes go for you reading the question and trying to understand it. Okay, so in the worst case you have 30 minutes, 25 to 30 minutes. In the best case you have hardly 45 minutes for the problem. Okay, so the question should be such that uh, the candidate can actually solve it. For example, if you ask somebody to sum, then yes, it's a reasonable thing that if somebody has not seen this problem before, he will think and try to come up with a solution. That person might start with n square solution by using two for loops, then might go and think about maps. Okay, great. So that's something which can be thought. If it's a a company which has very which sees a lot of applications from the candidates, then they can ask these kinds of questions like trapping rainwater, because they want to filter out candidates. They are expecting the candidates to be solving the question at that instant, but actually they know that candidates know the answer. But even though if somebody is such that they have not seen this problem, they can think of this problem and solve. But there are some questions which are like uh, median of stream, that question, or the video which I uploaded a few days ago about that median of two sorted arrays. So these kinds of questions, they cannot be done in 30 minutes. Let's be honest. They cannot be done in 30 minutes. When I take the interviews of the candidates, I never ask those kinds of questions. I ask the questions which are on the easy medium side or the medium questions, and that too also not focused too much on the implementation or the algorithms. If it is something that the person can think iteratively and come up with, then that kind of questions can be asked, and ideally those kinds of questions should be asked. Okay, I also don't care if the candidate cannot write the code for the solution, as long as candidate has given a uh, as long as the candidate has walked me through all the steps or all the thought processes that had gone in his or her mind while solving the question. I am good. I select the candidate. Okay, okay, enough about the interview process and all. Let's come back to the problem and let's see the problem statement. So the problem statement says that you have n non-negative integers. Okay, so you have n non-negative integers which represent an elevation map. Okay, so they represent an elevation map. Okay, so for them the width is 1. Okay, width is 1, height is different. Okay, height can be different. Okay, so you have to tell how much water it can trap. Okay, how much water it can trap. So the thing is, first of all, you cannot know what volume of water will be trapped in a 2D. Okay, so for simplicity we assume that the water's unit that we are talking about, it's not in volume, it's not in meter cube, liter or liters, it's in units. Okay, so 1 unit of water, 2 unit of water, and we will fill the unit later. Okay, so don't think too much about, don't try to visualize it that how we will calculate the water volume in a 2D. Okay, next. So let's understand it through an example. So let's take the test case which is given here. So the test case is, so there is a height array. Okay, and the numbers are 0 1 0 2 1 0 0 1 0 2 1 0 1 3 2 1 2 1 1 3 2 1 2 1. Okay, so these are basically the elevations. Okay, these are the elevations. Now you have to find out the volume of water or the units of water it can hold. So to understand this, let's visualize it. Okay, so let's say this is the elevation graph. So this is 1, this is 2, this is 3, and as the problem statement says, width is 1. Okay, so we have total 12 things, right? So let's mark 12 one width each. 1 2 3 4 5 6 7 8 9 10 11 12. Okay, and now let's mark the height as well. So the for the first one, height is 0. Okay, for the second one, height is 1. Okay, for the third one, height is again 0. For the fourth one, height is again 2. For the fifth one, height is again 1. For the sixth one, again height is 0, then again 1, then 3, then 2, this is 3, this is 2, then again 1, then again 2, then again 1. Okay, now you see this is boundary. Okay, so this is empty space, and to the left of it is also empty space. This is not a boundary, this is empty space. So any water which is present here is like wasted. Okay, so the water that can only be stored is this. Okay, the water can be stored here, right? The water can be stored here, the water can be stored here, and that's it. These are the only 3 places where water can be stored. Okay, so if you see 1 unit of water here, 1 unit of water here till this point, then you can see 1 2 and 3 units of water here. Okay, so 1 unit water here, 4 units of water here, and 1 unit of water here again. Okay, so total answer is 5 units of water, or sorry, actually it is 1 4 1 6 units of water can be held at this. Okay, so this is the problem, how much water it can hold. So if you see here, no water can be held, here no water can be stored again. So the only place where the water can be stored is if it is surrounded by 2 walls. Okay, and one wall should be of a smaller height than the other wall. So if you see here, this water is stored here only because this wall has a smaller height than its left and right. This wall has a lower height than this. Okay, not exactly this. So this wall with height 0 has lower height than its left and right. That's why the water is stored here. So these kinds of things we need to take care of. Okay, so how do we solve this problem? So the way to solve this problem is to first, you can take all possible combinations that, okay, how much water will be stored here, how much will be stored here. So you can go like this, that, okay, here height is 1. So you start iterating. Okay, height is 0, then height is 2. So for also notice one thing. So if there is a wall like this, okay, and there is a wall like this, the water that can be stored in between these two will depend on the height of the minimum one, which is the minimum. You cannot have water stored like this, right? Because this will flow out. So the only water that will stay is the water which is present here, right? So that's why this is another important thing. It will depend on the minimum height wall. Okay, great. Let's start. Also, before that, let's try one more test case because Leetcode has given 2 test cases, so we'll try the other one also. Now the other test case is 420325. 420325. Okay, so if you see again, width is 1, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. Okay. First one is 4, 2, 0, 3, 2. This is too much. 2 and 5. Okay. So now the water is, see, this 5 is the maximum height and it is bounding it from both the sides. So now the water height is this. Here if you see, 1, 2, 3, 4. Okay, sorry, this is 4 and this is 5. Sorry, my bad. This is 5 actually. Okay. So now till this point, okay. So you see 1, 1, 2, 3, 4. So till this point it is storing 4 units of water. Here it is storing 2 units of water, 4 to 6. Here it is storing again 1 unit of water, 7, and again 2 units of water here, 9. So the answer is 9 in this case. So again 4 units here, 2 units here, 2 units here, and 1 unit here. So these are the places where water is stored. Okay. How do we solve this? How do we solve this? So for this, we can do something like iteration from both left and right end, because it is not possible for us to find all possible combinations. So let's try on this. 4, 2, 0, 3, 4, 2, 0, 3, 2, 5. Okay. So we know that, okay, 4 is here. We know that 2 is here. How will you keep track that, okay, since 2 is less than 4, it means 2 must store, 2 must be storing some water. We might find out in future that how much water 2 will store, because it is bounded by a more height wall from its left. Okay. How will we keep track of that? Now again, 0 is also there. So we also have to keep track of how much water 0 will hold, because 2 is on the left of it. Okay. Now we come 3. Now we see 3. 3 again. Now we know that, okay, 3 is there and 0 sees that its left and right both are of more height than this. So it can say that, okay, there will be some water which will be stored between 2 and 3, and the unit will be, as I said, the minimum of 2 and 3. So the unit of water that will be stored will be 2, right? Because it's like this, 2 units here, 0 unit here, and 3 here. So the water that will be stored is this point, which is 2 units. Yes. How will you keep track of that? You cannot. Okay. So it's like all possible combinations. Yes, if you can do that, do that. But the optimal approach is to start a loop from left and right side. Okay. And as I mentioned again before, that we have to focus on what is minimum. Okay. So we start a loop, while loop, from left and right. So our loop goes like this. Now we also need to keep track of, as I mentioned, whenever 0 came, 0 knew that in left it has 2, it has 4, which will help it store water. So we will take something called left max, and we will also take something called right max in its left and right. Okay. Now we will start. So for now, left max is 0, right max is 0. Okay. I is 0 and j is at the end. Now we see that, okay, since I is less than j, I is means height I is less than height of j. So 4 is less than 5. So in that case, whichever is lower, we will work on that side. We will calculate, we will do the calculations on that side. So here 4 is less than 5, right? So now we will check if 4 is greater than left max. Okay. If 4 is greater than left max is 0. Is 4 greater than 0? If 4 is greater than 0, then yes. So we'll update left max. So we'll update the left max with 4. So now the left max is 4. Okay. It means if 4 is taller than left max, it means that there is nothing which can store water from 4, because see, if left max is this, okay, here. So when we come at this point, we know that left max is what? This 2. Okay. So yes, this 2 will hold some water for this. But if we have this and this, then we know that if this is there, then it will not help in holding any water, because all water will flow out. You might ask, what if this is the case? Okay. In this case, yes, it will help in holding water till this point, but after this it will flow out, right? So that case is considered when we are calculating for this point. For this point calculation, this water will be calculated. I will show you how. Okay. So that's why when a newer one comes, okay, that which has more height than the max height so far, then it will not contribute anything to holding water and the water will flow out. Okay. So if height of I is greater than left max, if height of I is greater than left max, in that case we will update left max. Okay, we will update left max. Left max is height of I. Else, okay, so this is if. Else water will be calculated. Answer will be answer plus left max, whatever is the left max till now, minus height I, height of I. As I told you, if this is of height 2, this is height 0 and this is height 3. So when we are here, left max is 2, right? Now when we came here, left max is still 2. Okay, this is left max is still 2, but the water that it can hold is left max minus height I. So 2 minus 0, it can hold 2 minus 0 water. Okay, and it will always be on the minimum side. Minimum side means whichever is minimum in the I and j. Okay, so we'll do that, and once the calculation is done, we will move I from here to here. Again I is less than j, we will again do the same calculation. Again we will move. Okay, again we will move, the I will keep moving. Okay, same thing goes for if at any time height of j, okay, when j becomes less than I, then we will do the same calculation on the right hand side. So again, this time this height of I will become height of j. Okay, this calculation left max becomes right max. Here again left max becomes right max equals to height of j, and answer is equal to answer of right max minus height of j. So this is how it will happen. Let me dry run and show a solution to you, and then you can try coding it yourself. Okay, so let's try something in which we are moving both left and right. Okay, 4 2 0 3 6 2 7 not 7 5 3 and 5. Okay, let's try this. So we have I, we have j. Okay, we see that 4 is less than 5. 4 is less than 5. It means our calculation will be on the left side. Okay, we know that left max is 0, right max is 0. Okay, now we calculate 4, height I is less more than left max, right? So our left max will update to 4. Okay, now nothing we can do, so I will move forward. So when I moves forward, now we know that this time height I is less than left max. So in that case, our answer will be what? So we know that actually 2 is first of all, sorry, for the first one, let's iterate for everything. 4 is greater than 0, so we updated left max. Now 2 is less than 4. So since 2 is less than 4, to show you what I am doing, I am comparing here left sorry, no, here I am comparing height I and left max, height I and left max. Okay, I'm comparing these two. So we'll come back. 2 is less than 4, so the 4 gets 4 is greater than 0, so left max gets updated to 4. Now 2 is less than 4, so our answer gets updated to 4 minus 2, which is 2, right? So our answer is 2 plus. So again I moves forward, I here, again I is greater than left max, right? Sorry, I is smaller than left max, right? So it means 0 is less than 4. Now what we do is, again 2 plus 4 minus 0, 4 minus 0 is again 4 plus, again I moves forward. So now we compare 3 and 4. Again we see that yes, 3 and 4 is again 4 minus 3 plus 1. Also, while we are doing this, while we are moving I forward, we are still comparing I with j. We are still comparing I with j. So first we calculated compared 4 and 5, then 2 and 5, then we compared 0 and 5, then we compared 3 and 5. Now we again moved forward. Now we compare 6 and 5. So 6 is greater than 5, right? So since 6 is greater than 5, what we do is we updated right max. We updated the right max to 5, and then we moved j here, right? We moved j here. Now we again compare I and j. So again you see 6 is greater than 3. So since 6 is greater than 3, again the calculation will be on the right side. So we know that 3 is less than 5. So our answer will have 5 minus 3. So it will be again 2 plus. Now this j comes here. So since j comes here, now we again see when we calculate 6 is again greater than 2. So in that case we will calculate from the right side. Right side is again 2 is less than 5. So 5 minus 2 is 3. So we will add again 3. So the answer will be 4, 2, 6, 1, 7, 2, 9, 3, 12. Because after this I and j, they just match. Okay. And our while loop will be while I less than j initially. So when I and j match, we will just end the loop. And you must have seen why we are doing calculation from the minimum end, because here see 6 is the max, right? So 6 will not contribute anything, right? Because 6 will contribute to the overflow of water. If we use 6, it will give us the wrong answer. It will give us the wrong value. It will just overflow it, right? So that's why we do not take the maximum one, we take the minimum side. Okay. So I hope for this dry run the answer is correct. Let me try to feed it in my code and see if it is actually correct. 42036 42036 235 42036 let's run it, and if the answer is not 12, I'll have to do it again, and the answer is 12. So this answer is correct. My dry run is correct. Dry run is correct. Okay. Yeah, I don't know why I wrote it, but yeah, I'm happy that it is correct on the first attempt. So yeah, that's it. I'll ask you guys to try this code on your own. I have given most of the algorithm, so there is nothing much you need to write or you need to think from your end. So just try to convert this dry run and algorithm into code and you will get it. If not, I have added the solution link in the description of this video. Please use that to understand more. And yeah, I am done here. Hopefully you find this video helpful. If yes, please like, share and subscribe, and I will see you in the next video. Thank you.